Okay, thank you very much, guys, for joining us. This is a session organized by the Early Career Researchers Group, and we're actually here as informal chat about the topic that we actually create. So we have several sessions like this, and this one will be led by Tim about how did we call it? Machine learning and neural networks. And we have actually, I'm checking right now, 132 subscriptions there in VUA. So, and 33 participants right now. Anyway, the main idea of this event is to have informal questions, chat. You can ask questions to the audience, actually, or you can ask directly team, something that is relevant to machine learning and neural networks. And yeah, and basically feel like you are really on the conference and we're meeting somewhere for drinks. In the UK right now it's dark, as you see, and actually, yeah, so let's have this informal meeting. Let's say it like this. So, any questions from the audience or anyone who wants to start? Team, thank you very much for joining us and for agreeing to host this event. And
yeah, sure, it's my
basically
pleasure.
maybe yeah, let's actually start maybe with your introduction, the short one, and then I guess we will get some questions.
Yeah, so when I was super happy to moderate this session when you know, Shari and Mia, or when they reached out. I did an earlier session with the early career chapter on sort of what it's like to you know, start a forecasting career in industry. I myself happen to you know, my background is in discrete optimization, sort of classical artificial intelligence, and then my first job, I joined SAP and worked one of the, you know, big fortunes maybe of my life is I worked with Stefan Kolassa, who's an forecasting expert, and he's also, you know, very visible typically at the ISF. And then I got into forecasting, sort of stuck around when I moved to Amazon about 7 years ago, and I've been I joined Amazon as a researcher, where I, you know, developed algorithms and systems for forecasting at a large scale. And then about 5 years ago, transferred into a management position. So this was around about the time when sort of the deep learning revolution was also, you know, starting to get to the forecasting field. So I'm super happy to be moderating this session. I think the idea is, you know, this wouldn't be a successful session if it's me talking the whole time. This should be really interactive. I've prepared a couple of questions that we can, you know, can kick off the discussion. But maybe before I hit you with all kinds of questions to the audience, maybe there are questions already, or, you know, things, controversial statements, you know, anything that you would want to share with the audience on this topic that we have today, and that is machine learning and neural networks.
Hi, Tim. Yes, thank you so much for being with us tonight. I think we're all very happy to have an expert like you among us to answer our questions or to discuss with. So what I see is that now in research and academia, there's a lot going on about machine learning and neural networks. But I was wondering, is the industry like ready for it? Or are there things that you see, these are the big challenges for industry to really, let's say, adopt this whole machine learning neural networks in practice?
So I want to resist the urge to answer this, to jump into a question, to jump into an answer. And I want to sort of, I think it's a great question. I want to pass it on to the audience here. I think there's a couple of not so early early career forecasters here on the call who could take this question. Or also, you know, someone who's maybe done an internship or something like this.
Well, I can take from my experience. So that's Slavik speaking. Hi.
Hi, Slavik. How are you doing?
Hi. All right, thank you. How are you? So, you know, what I can see around, that people definitely are not only interested but doing that. It may not be majority of projects, but even if people do some traditional methods, they try to augment it with you know, machine learning, and definitely there is the neural network are definitely of interest to data scientists. It just looks better on CV, is more interesting, more sexy. So it's definitely something to do if you have. Yeah, it happens quite often, although maybe still minority, but it's growing. It's growing. Yeah.
So a couple of folks who have themselves. Thanks, Slavik, for the answer. There's a couple of folks who've unmuted themselves. Maybe you want to. Is this because you want to talk? I think I've seen Adam here. Okay, I'll take silence as a no.
Maybe question. Can you hear me?
Yeah, and yes, I can hear you. Maybe one thing, if you talk, could you switch on? You know, unless you're in a compromising situation, could you switch on your camera so that we can see you?
Okay, let me try. I just moved to that, but yeah. So, okay. Hi, my name is Anton Yakovlev. Just maybe a beginner's question. When you speak about neural network and forecasting, so what is from your experience a point when you shall switch to neural network in terms of amount of data or history in your time series? Can you hear me?
Yes, I can hear you. Yeah,
I mean, like let's say you have, I don't know, if you have weekly time series, so you have each week one data point, and like how many years, like you need of history.
Yeah. Oh, yeah. Actually, sorry. One thing that we could do here to make this more interactive, if you introduce, you know, if you ask a question, introduce yourself maybe briefly, what you're working on, what your sort of background is in this area, and what I think that would help others also in making this a bit more interactive.
Sure. In 2 words, I'm working at Robert Bosch as a data scientist, and we're doing time series forecasting for demand and sales. Yeah.
Cool. So the question was
I've been working mainly with gradient boosting models for now. Yeah.
Right. I think Sarah had an earlier question that Slavik answered. Do you think, like, what's your experience like? So you said gradient boosted trees are being used in your area. Do you also use neural networks? Is this something, or basically machine learning in general? Are there any friction points that I think that Sarah mentioned there from your daily life? And then we'll get back to your question. Sorry, but I do want to make sure that, you know, we're engaging here with the audience. So Anton, that was a question for you. Sorry, like machine learning and gradient boosted trees, or, you know, non-traditional models, I would call them. You know, what like how and neural networks, of course, how pervasive are they from your experience in industry?
I mean, with neural network, I don't have much experience, but with boosting models and maybe more classical, like usual, like ARIMA things, I think it really depends on the data quality, I would say. Yeah, maybe classical models like ARIMA, they need lesser data, for sure. Yeah. Yeah, so I'm kind of curious what is experience of people on neural networks and when it's a good indicator to start using neural network in terms of data, how much data you need, more or less. Maybe a bit naive question, but it's a beginner's question.
No, I think it's a perfectly fine question that I think the community has been wrestling with that question for some time. I think if you think back in the first wave of neural networks, I think there's an overview paper from 1998 or something like this, one of the most cited papers in the IJF. They were using neural networks very much for single time series use cases, and they weren't doing great. It was a mixed bag of results. Nowadays, I think people are mainly using neural networks as global models, right? So you don't have a single time series, but a set or panel of time series, and you throw it at the neural network. I think the magic number I used to think holds is like something like 10,000 data points. Now this is when you start seeing superior performance. So like that's the number of time steps times the number of time series you have. But you know, I think the state of the art is rapidly evolving there. And now I fell into the trap of answering the question. I want to go through the participants here. Also, Carlos, you're unmuted. Is that a sign that you wanted to contribute to this discussion? Okay, it isn't. Slavik, you wanted.
Slavik, please go ahead.
Sorry.
Slavik, were you trying to say something?
No, I wasn't sure who is going to do. Okay, so you said 10,000 points. I think it's a good rule of thumb. My rule of thumb is that, you know, below that there is a good spot for the tree-based algorithms. So neural network, they need more data before they can beat tree-based algorithms. So, you know, if you have like 20 time series, maybe some Bayesian model hierarchical. If you have a little bit more, then, you know, tree-based algorithms, and if you have still more, then neural networks. That is some sort of rule of thumb.
Yeah.
So Anton, Michael here. I also doing the research for demand planning, and I'm really trying to use the neural networks there. And I'm also struggling with the problem that it's really tempting to use the neural networks. However, it's usually the very short sample that you have. And on top of that, I'm also trying to use the Google Trends as exogenous variables to help for the predictions. And I also trying and I'm digging up into answering how those neural networks can actually be used, if at all. Regarding the question, is it useful? I unfortunately have the same remarks as Tim says, that even though it's possible, usually the performance it's not superior, to be gentle here, comparing to the traditional models like ARIMA or tree-based algorithm here. However, what I what I found out that what actually helps is what Tim has also mentioned with the global models. When you have the panels and you have the batches that you send it, what I'm doing is when I have the time series, for example, for 5 years, which allows me to make those batches, I'm making a window for 3 years, and this window is one batch, and then I'm moving to using the rolling window and use it as a batch, and that brings some improvement, but still I cannot beat the simple autoregression here. The second thing what I have started to work on, and I completely forgot for today, so I'm sorry. I know that there is the part of the algorithm which make the matrix of the weights sparse. So when you, and Tim, please feel free to elaborate on that, because I will just briefly mention it if you know.
Drop out, or what do you mean?
So there is a part of algorithm that I remember that when you try to estimate the weights for a neural network, part of the weights are forgotten. Yep. So thank you. So I'm also using the dropout here because it's, as you believe, it's very easy to overestimate, and therefore the results are bad. So long story short, what I wanted to say, if you have long time series enough, using the rolling window and using as batches shows that there is a little bit better performance, but still cannot beat the econometric models here. And maybe the dropout will also help to fight with those overestimation here. And I have to stop talking because I cannot say another word.
Thank you for your experience. Thank you.
Happy to share.
Mm-hmm.
And someone, sorry, I interrupted someone when Slavik started speaking. I'm sorry, I don't know who that was and who started talking. Maybe you want to continue talking.
Now, one of the person, it was me, but I have already answered the question already.
Oh,
so
okay.
I wanted to say what I wanted. So.
Okay. Okay, then I think one of my prepared question is, to poke folks here a little bit. There's this ongoing controversy here in the forecasting community, so about machine learning versus statistical methods, or traditional versus new. What's your opinion on this? Would anyone sort of have? Would anyone sort of agree with that? Demarcation, or does anyone think this is something that you would want to you want to argue against this this kind of distinction? And again, if you want to if you haven't spoken yet and want to make a statement, please introduce yourself briefly.
Tim, if I can intervene, I'm Jacopo De Stefani. Can you see me?
No, but I can hear you crystal clear.
Nice. Now you should be. I also see myself. So, and yeah, that's an interesting question, and I would like to share a negative experience I had about that, which is basically the fact that I spent the first years of my PhD trying to basically compare one against each other and try to find out which one was the best. And in the end, what I realized is that, of course, that's one of the results known also as a no free lunch theorem, that there is no model which is the best one for any possible case, but that's also combining the different model either in an ensemble way or in a more structured way. So having some parts of your forecasting model that use statistical technique, for example, for doing feature extraction, and then using these features as input to a machine learning model was going to improve the forecasting performance I had. So that's my take on that. It's sometimes one is better, sometimes the other is better, but usually by combining them, you can take the best of both worlds.
But do you think it makes sense to, like, this distinction even makes sense into machine learning and statistical methods? Is it a useful distinction?
If you try to dig deep enough, machine learning is, in my opinion, basically a form of applied statistics. So, I mean, you could argue that a machine learning method is indeed some more complex form of a statistical method. I mean, yeah, it's just a matter of classifying thing. I do agree that I mean, it could make sense to make a distinction among them. But yeah.
Okay, thanks.
So, I mean, I guess jumping off of what Jacobo says, my name is Paul Sangari. I'm also an economist. I'm an economist. I also work at Amazon, similar to Tim, although we're not on the same team. And I guess, definitely, I guess I would be tempted to argue that the distinction between machine learning and applied statistics is maybe a little bit, hard to pin down if it's even interesting. But of course, there's like a deep learning, is maybe a particular type of machine learning algorithm, and like it's definitely different than many other machine learning or statistical algorithms. And I guess I would be curious to hear people's thoughts or experiences with trying to combine various sorts of deep learning methods with maybe more traditional econometric methods. I know some of the stuff we've been doing has, I think, had some interesting experiences there, but I'd be curious to hear other people's thoughts.
Okay, so I think the question Paul was asking is if there's any value that you're seeing between and combining neural networks with probabilistic classical statistical models. Okay, now I said statistical models, but like classical traditional models. Slavik switched on his camera, of course he knows.
Actually,
anyone?
Sorry, go on, yeah.
I
want to say something about previous question about the statistical and then machine learning, and I just really observed that, this is definitely a question of culture and where people started from. But when I look at these new papers appearing, really it's going to merge. I mean, people are getting more and more sophisticated, building neural networks using, really ideas from what do you call statistics, and thing. I saw a paper which was talking about this stick breaking processes and the polya urns and so on, and it all funneled into a neural network. And other side where I saw people talking about Monte Carlo going somehow faster through neural network and stuff like that. So I think it's slowly getting merged. It's just tradition. So that's my
right. And back to Paul's question. If anyone has in this audience experience with probabilistic and deep learning models. Nicholas, sorry, I saw you use the hand raising feature. Or is this an answer, or?
Yes. Can you hear me?
Yes.
I'm a PhD student of the University of Hamburg, and I think the main difference is that for forecasting, I would prefer machine learning and neural networks, but for partial effects, I would say regression analysis is more advanced and more precise, but there are some algorithms how to open the black box of neural networks, like the importance criterion or Lex profile method algorithm. But I think in the point of partial effects, so the independent on the dependent variable, regression analysis and statistical methods is still more precise, whereas machine learning is better for forecasting.
Okay, I think that's, at least I partially didn't understand that answer. And Paul, from judging from your face, did you get that?
I mean, I think I got what he, I guess, I mean, the point, if I understood him correctly, which I very well might not have, was, and I think I'd agree with this, that if you're interested in some sort of model causal analysis, using a neural network for causal analysis is probably going to be quite difficult. I think I would agree with that. That's a little, maybe there's something you could do. I guess I would, like what we've been doing, I think it's actually some stuff that Tim has done in the past, is trying to do like deep learning on neural networks and state space models simultaneously, and trying to get the best of both worlds there. And at least what we've been doing so far, I think, has proven quite promising, because I think you can, well, in some very sense, neural networks at the bottom layer are just very, very simple statistical models. And if we could take some of the, multitude of models that have been developed that are more probabilistic based, and then marry them with neural networks, you can get, I think, you can get a lot of the scalability and stuff that you get from a neural network while still maintaining the interpretability or probabilistic structure. But definitely is not something, I guess, as Slavik was saying, I tend to think these things are going to eventually merge over time.
Yeah, I think, yeah, I mean, from my personal experience, it's really, you have to, it really comes down to what kind of problem are you trying to solve? Is it like, are you in this big data scenario where, where essentially everything is encoded in data, and you just, need a really, a model with a high capacity essentially to extract all these information out of it? Or do you have some kind of constraints that you're in a lower data scenario, or you want to impose some structure on the model, let's say some seasonality? And then I think, yeah, this probabilistic models where you, for example, in a state space model, right, where you can have some kind of imposed seasonality, can be very helpful to make sure that as you're extrapolating, you don't run into anything crazy. You don't have any crazy failure modes. Maybe also wanted to go back to one question that came at the very beginning. I think, Sarah, you asked this, are neural networks used in industry? I think it's one of those areas where actually industrial science or industrial applied science is maybe ahead of academia, because I think if you look at publications from Uber or from Walmart or from Amazon, I think there's some real evidence that for a long time there, before the M4 competition, also neural networks have been used a lot. I wanted to double click maybe on a point that Slavik and Paul also mentioned, is around this merging of statistics and machine learning. And I think there's a very concrete aspect to it, in the sense that many of the deep learning frameworks are actually very powerful tools to actually program, to write, specify interesting forecasting models. So I was wondering if people are, in the audience here, if folks are using any of the major deep learning frameworks, and what the experience is. Niklas, you still raising your hand, but I guess that's not for this question. Is it? So maybe I'll pick out some folks I know. Mitchell, for example. I'm not sure if you've been paying attention, but what's your sort of take on neural networks, deep learning frameworks, whether they're useful tools for programming?
I believe Mitchell has answered
Okay.
the question in the chat.
Sorry to having put you on the spot there. Thank you.
At the risk of monopolizing the conversation, the way I tend to think about these neural network frameworks is that they're very sophisticated ways of basically utilizing two technologies, automatic differentiation and dynamic computational graphs. And so they're basically very sophisticated ways of combining very simple models so that they can be very scalable across, in terms of the amount of data that they're using. And definitely in cases where you have the amount of data where something like that is a useful property, they can be quite useful. And there's nothing really inherent about a multi-layer perceptron or something like that really, it's more about the automatic differentiation, dynamic computational graphs, GPUs, that sort of thing.
So if I can add a bit, definitely things like PyTorch or TensorFlow, you can really program them, right? It's people, you can use it at the level of someone wrote a script by just modify parameters, but you can also program and it may go further than adding one layer two. You can add really logic there, if then and so on. So this is ability to really program is great. So this is kind of at the level of user. But then you have also people who use neural network to write like probabilistic programming languages. Pyro was written on top of PyTorch. There is TensorFlow probability written on top of TensorFlow, right? And in Facebook there is another project going on to create new probabilistic programming language. So this neural network frameworks are useful as a tools for doing something on top.
Yeah, definitely. I mean, that's, I think, one of my personal, experiences is that, writing probabilistic models or, writing coding up something can be very, very hard, right? Especially if you have to calculate gradients on paper. If you're a PhD student, you can spend much of your PhD thesis deriving gradients. With auto differentiation, which is typically integrated into neural network frameworks, those days are gone. And I think they give you an immediate scalability. So I found them very, very powerful. And in Slavic, I think the Slavic is saying lots of probabilistic goodness is already included in them. So I think that's where this whole merging, of the fields, I think will become very, very tangible. I think PyTorch and PyTorch has, there's PyTorch TS and PyTorch forecasting. There's two packages on PyTorch. In PyTorch, especially geared at the forecasting community. Gluon TS, of course, which now supports PyTorch, which we develop in my team. That's another one. But wanted to give this back to the audience again. If there are further experiences folks had maybe frustrations with terminology in that respect, or maybe also something completely different.
Hello, can you hear me?
Yes.
Yeah, awesome. Hey, I'm Vladimir. Just wanted to jump into the conversation. I just saw Slavik talking, and I'm a little bit late to the party.
Can you
Sorry
also
about.
quickly introduce
I'm
yourself briefly? What are you doing? And
I'm Vladimir. I'm from St. Petersburg, Russia, and I'm a team lead at quite a big company about gas and oil and stuff here in St. Petersburg. So we do forecasting, demand forecasting, this kind of stuff. Also, I was in heating demand, electricity demand forecasting for some time. And actually, I've been using for quite a while the approach which Slavik promoted in a way. So I'm kind of a big fan, as always, the ESRNN, right? So I also wrote my own using PyTorch with double seasonality, this kind of stuff. And I was kind of happy with the performance. I liked the work which Slavik did actually to implement this thing. And I wanted to probably ask Slavik, what are the next steps? Because you were working in this kind of approach for quite a while. I read your code in Dynet, this framework on C++. But like, what are the next steps? Are you actually building something on top of that? Are you somehow developing this approach further? Just curious about your work. What are you working on currently?
Okay, so I did improve it a bit. I believe, you know, I participated in M5 competition and it didn't go very well. But I did develop a few improvements, although they are kind of like you run several concurrent neural networks, and there is something which decides weights between them during runtime and stuff like that. It's still the same vein. It just sort of, you know, gradual improvement. Other than that, I'm really interested in this idea of specialist or clustering, you know, and for example, I'm trying now to thinking about like how to, you have 10,000 time series. Possibly one of them is predictive for another one, right? But how to find the one which is how to find good friends between them. So one of them is helping the other one to predict. So this kind of issues, you know, I don't, yeah. So yeah, and I don't like to write papers. That's the problem. But maybe one day I'll put it up together and write. But yeah, I have a few interests, but nothing groundbreaking. Yes.
Yeah, I think I have the same problems. I see a lot of SKUs which are similar to each other, and I have mass forecasting problem. And I'm also thinking how to reutilize like those features which I really like using your approach. Because actually, I wanted to also ask, your approach is about like just using ES and then LSTM, but it doesn't use any exogenous regressors, right? Did you think about including exogenous regressors somehow? Because it's a crucial thing for me. And I was trying naively to add that kind of stuff to LSTM, but it usually was overfitting. I was fighting with that a lot, and I didn't really succeed with this. So did you have any experience with exogenous regressors in this case? So,
you know, actually, this is something, you know, I didn't have regressors in M4 because there was no regressors in M4, right? But if you have, of course, you use them. And as a matter of fact, I think that was mentioned earlier during this talk. You know, when to use traditional time series algorithm, when to use this. When I would say simple thing is when you have regressors. You know, then it's shame not to use machine learning. If you have naked time series, well, that's not obvious. But if you have good regressors, shame not to use them. And then machine learning obviously is something. Well, I don't know. You said overfitting, that's dangerous, but you know, it's always with neural networks there's danger. And I always do this validation and early stopping. And of course, neural networks are sensitive to normalization, right? If one of your feature is 10,000, another one 1, you need, you need to squash them.
Yeah, but I think that's a general purpose. That's a general property, right? It doesn't, that holds also for other, global models.
Yeah,
to normalize that things there.
Well, I mean, it's tree-based are more forgiving, but neural networks are analog, so they are.
No, I mean, just the thing is that maybe it was a problem of my implementation, because like once I added those external exogenous regressors, the model couldn't pick up the right kind of Holt-Winters coefficients, like the exponential smoothing coefficients. So it was mostly paying attention to external stuff rather than the core of your methodology, which is the removing the ES components like the trend and seasonality off first before the LSTM layer. So probably just problem of my implementation, but at the same time, I always remember this mantra of Mr. Heinemann that you cannot use external regressors with exponential smoothing. There was a paper about this, and I was trying to read it and grasp the essence of it, but still I was thinking, like, is it really going to work at all? Maybe it's just some theoretical implementation, limitation, which I don't understand. That's what I was thinking of when I was asking this question.
Yeah. I think most important is experiment at the end of the day,
Yeah. Well, I spent a lot of time doing this, and that's why probably I like it so much, because I invested a lot of my time, and that's the bias we humans have when you invested so much time into debugging this thing. Yeah, thanks for your answers. That's really interesting.
Anton has a question for
Yes. Can you hear me?
Yes.
Yep.
Okay. I'm trying to activate my video, but okay, it should work now. I have also a general question, maybe changing a little bit topic. I think at the beginning, Michael mentioned dropout, right? And then we've been talking about like frameworks, PyTorch versus TensorFlow. And please pardon my inexperiences, but I think like dropout is patented by Google, right? So that's why, I mean, it's very useful as far as I know. Are there any alternatives in PyTorch? Because I think PyTorch is actually much nicer than TensorFlow. Gives you maybe the same level of flexibility, but much more understandable. So is there an alternative to dropout in PyTorch, or maybe some other alternative methods?
Again, I want to sort of resist the urge to answer this. Anyone from the audience who wants to?
I can say that. Yeah. So the Google patented that, and that's very sad. But that's what companies are doing for commercial reasons. I kind of doubted they will enforce it. And when you say PyTorch is patented on TensorFlow, dropout is patented on TensorFlow. Dropout is technique. It can be easily written in any, MXNet or PyTorch or any neural network program. You can implement dropouts. So it's not tied at all to TensorFlow. It's literally just few lines of code. So the same way, I think Google patented this convolutional neural network, from what I heard. And
I was going to say that, yes.
So I until they start moving enforcing, which I don't, because usually these big companies do it for defensive purposes. If anyone dares to sue them, they will counter-sue with massive amount of patents. But typically, they don't use it in offensive fashion. So I don't think we should be concerned.
Okay.
Okay. Virginia has a question here on chat. And I assume I'll just read it out. I guess you can read it as well. Virginia is interested in probabilistic forecasting in the intermittent scenario. And there's a question if there's experience, especially for deep learning approaches or machine learning approaches that help with this, with especially the probabilistic intermittent demand forecasting. Is anyone from this group here has any experience you want to share? The M5 competition, of course, I think was very much about intermittent demand forecasting. I haven't personally seen any sort of model innovation coming out of the M5 competition. I think the M4 competition in that regard is a bit of an outlier, where there was actually a model innovation. So we've been using lots of fusions of probabilistic models here with deep learning models. I think just vanilla deep learning models, if you use an appropriate likelihood, negative binomial or any kind of zero inflated stuff, or Poisson plus something would do probably pretty well. I think there was a 3D loss that was quite successful in the M5 competition. So I think sort of standard neural networks work. We've been experimenting lots with renewal processes, who we think are a pretty cool tool for handling this really in a principled way. But that's sort of my experience. And I wanted to give it back to the audience here. If anyone else had experience that he or she can share with Virginia. Okay, I'll take silence as a no. But yeah, I think for me, this intermittent demand forecasting problem is really one of the most interesting problems we have, because it's so pervasive in practice also. And Anton says 3D is good. I think there's a deep AR implementation in PyTorch using the 3D loss, which I frankly wasn't so aware of before. Maybe another prepared question I have is, what do you think are the big challenges that you think you will be seeing here in the machine learning neural network area? What are the big problems that you think we can solve with those tools? I think Slavik mentioned something around clustering, find metrics, find time series that correlate strongly with each other. Folks are looking into multivariate problems more and more. And I want to ask the round here, what do you think are exciting problems that you think will be able to tackle better with machine learning and neural networks techniques?
Well, I can add a few cents here. I was thinking a lot about the hierarchical time series, and the case when we really need to forecast on multiple aggregation levels, right? And it feels like this approach can be handled by neural networks pretty well, in my mind. I haven't seen any like real implementations. Maybe you could shed some light on this. Maybe you know some implementations or work on this, because it's like a real thing which we need for our purposes, for example, for demand forecasting. And there were a few separate sessions on obviously hierarchical stuff and new algorithms, but merging these classical approaches and approaches which already exist with neural networks. I'm just curious, like, can you do it? Has somebody tried actually doing this? I thought like maybe that's where we could innovate in the future. Maybe somebody could also add a few things about this. Maybe somebody experimented with hierarchical time series and neural networks.
I mean, this is an early career.
Okay.
These the early career chapters. So maybe someone is writing a PhD thesis on this. I think Oscar, did you want to say something? You had your camera on.
I'm not sure if grey hair qualifies for an early career, but if Oscar wants to take it, please go for it. But I'll make a comment if you want.
Yeah,
no, go ahead.
I was actually looking at George. I was looking at
sure.
George and thinking like it would be really nice if he could add his comments.
So there is
hierarchical
quite
stuff.
a bit of work coming out from Monash University with Christoph Bergmeyer's group in machine learning on hierarchical, various aspects of it. And also Vagelis Spiliotis and Rob Heinemann and Mahdi. So there is, this literature is leading to that, machine learning is entering this literature quite strongly. So keep an eye out for those. If you look at the Monash website, you'll find a few working papers on it already.
Thank you.
And I think if you want to stay up for a bit, Rob has a talk in an hour or so, hour 7 minutes on that very topic. Unless I screwed up with the GMT versus CET, I don't know.
It's in about an hour.
Okay. Okay, yeah, thanks, George. Anyone wanted to add to this?
Well, I can add. During M5, I was experimenting with, simple trick. Normally, you run batches, right, for neural networks. Now, imagine that batch size is not arbitrary, but is equal to your hierarchy. So each time series, you predict each time series, but at the same time, your loss function, because operates on batch, can put a soft constraints on difference between top level and bottom levels. So loss may be sum of errors plus sum of different between constraint hierarchical constraints. So that worked reasonably well, although didn't make a huge improvement, but it was sort of okay. So I think this is another example. Neural network are cute because you can have just idea and code it and try, and you can put any loss function. You can do a lot of weird stuff. So a lot of flexibility.
Yeah, I think yeah, that resonates strongly with the time from idea to experiment. You said, Slavik, that experimentation is so important, and probably that I mean that resonates strongly, and that many of the neural network frameworks sort of allow you to do that quite nicely. Yeah, I think one topic that I find is gonna, hierarchical forecasting is an interesting topic. I think multivariate forecasting is the other one that I think is we're gonna see much more of it. You think about the ARIMA, you have the ARIMA family of models, and then you have the VARIMA model, vector autoregressive models, and of course, estimating the dependency structure or the covariance structure, you can do much more flexible with neural networks. And there's a lot of very interesting work, I think, in the machine learning literature on how to model very complex high dimensional distributions. And I think we're not really using that enough. So I think that's something that I think is going to be quite interesting.
Yeah, Oliver, actually, that's why I was late to this session, because I was participating in that session about neural profit, and I think it's quite cool. Yeah, looks promising library. So and it's implemented on top of PyTorch, so of course we can hack it easily, unlike it's with PyStem, which is a little bit harder. So thank you, Oliver.
Hi, this is Thomas speaking. I'm a practitioner from Germany, and I would like to add a topic to the discussion, because you asked what about new topics, and I saw very few attempts to add something like data augmentation to the time series stuff we're doing. So we're having all these data augmentation stuff going on with the graphical models and models that are working on sound, but I haven't seen anything of that on time series data. And I wonder if this would be something interesting, or if anyone here has already seen works that do that.
Who wants to take a crack at that question?
Well, I just want to say, yesterday there was a session and people were talking about data augmentation. I know. So like yesterday, well, 2 a.m. my time, so I don't know. So like 10 hours ago or more, there was
I guess I missed that one. I missed that one.
Yeah. So first of all, people borrow time series from different domains. Like people, for example, people do M3 for M3 subset, but train on M3 plus M4, right? Or people try to generate a new time series similar. I mean, this is very tricky, but people try to do that, creating new similar time series. I'm skeptical, but people try to do that, and some report successes.
Yeah, I think one particular method I'm aware of is basically chopping up your time series and presenting in a sequence-to-sequence framework. Essentially, you can take any kind of natural language processing technique, pre-processing technique, almost any, and apply that, almost out of the box to forecasting. So, like chopping up the time series into different parts, and then having multiple training examples per time series, I think is one straightforward idea that we've been having some success with. And with this, I think we are at the hour. We had 1 hour for this discussion. I wanted to thank everyone for participating. I think many of the topics that we touched on today, they'll be covered by the conference or have been covered. Right, data augmentation. There's a hierarchical. There's plenty of hierarchical forecasting sessions, some of which I will try to attend. Of course, Rob Hindman's keynote. If you have any other questions or topics that you didn't get to ask, please send me an email or contact me over Woover, and we can discuss this offline. If you want to, I'd very much like to thank the hosts for organizing the session. Yeah, wish you all a great ISF 2020. Goodbye.
Thank you very much, Tim, for being here. And for everyone, there is more ECR sessions happening tomorrow. So check the WOVA app if you want to also be there. Thank you so much and have a great evening or maybe start of the day, wherever you are. Bye.
Bye-bye.